this is part 4. So what is a beach? A beach is any deposit of sediment that extends landward from low tide to a change in topography or where your permanent vegetation begins. So you can see in the diagram the extent of the beach. Now the beach is made up of the back shore, which is usually dry. It's covered by water only during storms or exceptionally high tides. It is also made up of your berms, which are part of the back shore, and they are composed of sediment that is deposited by waves. They are nearly horizontal or gently sloping landward. The beach is also composed of your beach face, that is the sloping area below a berm that's exposed to your wave swash, and the foreshore, which is the area covered by water during high tide but exposed during low tide. We can also get what we know as pocket beaches, and these are little isolated beaches that are in protected embayments. Now, your seasonal changes in beaches are primarily driven by changing wind intensity. So your strong storms are going to remove sediment from the beach and deposit them in offshore sandbars. You have what's known as a summer beach, where you have the beaches covered with sand and you have a wide berm. You also have a gently sloping beach face and a smooth offshore profile. And then you have what's known as a winter beach, where it's more coarser grained, it's steeper, you have a small berm or none at all, and your offshore profiles are going to reveal sandbars paralleling the shoreline. Now we do have some depositional features, like we just went over erosional features. So our first one that's shown in our diagram is called a spit. It is a finger-like projection of a beach into a body of water, such as a bay. A bay mouth bar that you can see illustrated in the diagram is a spit that has grown until it closes off a bay from the open ocean or sea. We have a tombolo, which is a type of spit that extends from the shoreline and connects the mainland with an island. It is caused by wave refraction and sediment transport. So some pictures. The top left, you see a spit. The top right, you see your bay mouth bar completely sealing off the water. And then in the bottom left, you see your tombolo that connects that land to the island. You might also have a barrier island. So a barrier island is a long, narrow island of sand. It parallels the shoreline, but it's separated from the mainland by a lagoon. And you can see this figure is a view from space of the barrier islands along the Gulf Coast of Texas. So the components of your barrier island, you will have a beach, you will have wind-blown sand dunes, and you will have a marshy area on their landward side. They form on the gently sloping continental shelves where your wave energy and your tidal ranges are low. So typically on the United States Atlantic and Gulf Coast. They're going to slowly migrate landward. There's 2 models for the formation of the barrier islands. They could have formed as spits that became detached from the land, or they formed as beach ridges that subsequently subsided. Our barrier islands off the coast of Louisiana and Mississippi would be Ship Island, Cat Island, Horn Island. So there's a balance between addition and losses of sediment in the near shore. We say we have a positive budget if I'm gaining sediment. There's a negative budget if you're losing sediment, and you're at equilibrium if the gain equals the loss. And this figure shows you how sediment can be added from erosion by longshore transport onto the beach. Sediment could also be blown inland by the wind. Sediment could be carried down the coast from the beach by your longshore transport. Now, we have different types of coast. We have what's known as a depositional coast, and that's going to be a coast that's characterized by abundance of detrital sediment and by depositional landforms, such as wide sandy beaches, deltas, and barrier islands. So the Gulf and your Atlantic coast are depositional coasts. Erosional coasts are steep and irregular. They lack well-developed beaches except in your protected areas, and you're going to have your sea cliffs, your sea stacks, and your wave-cut platforms. This is what we see in western North America. Now, some coasts do have characteristics of both. A submergent coast is also known as a drowned coast, and you can see the picture showing a submergent coast with estuaries such as your Chesapeake and your Delaware Bay. So these are going to be a coast along which sea level rises with respect to the land, or your land's going to subside. Prime example, like shown here, is the east coast of the United States. They could be caused due to the melting of the Pleistocene glaciers that cause your coast to be irregular. So when sea level rose, the lower end of these valleys were drowned, forming the estuaries like your Chesapeake and your Delaware. An estuary is simply the seaward end of the river valley where the seawater and the fresh water will mix. You could also have what's known as an emergent coast, and that's a coast where the land has risen with respect to sea level. So the emergence is going to take place when the water is withdrawn from the ocean, like occurred during the Pleistocene expansion of the glacier. Presently, your coasts are emerging as a result of your isostasy or your tectonism. This picture also shows a great example of a marine terrace, and you see sea stacks, you also see some sea arches. Now, we deal with coastal flooding, and coastal flooding occurs when large waves driven onshore by hurricanes and heavy rainfall. So as your hurricane moves over the ocean, the low pressure beneath the eye causes the ocean surface to bulge upward. You're going to have the storm surge, that surge of water onto the shoreline as a result of that bulge in the ocean surface beneath the eye of the hurricane and your wind-driven waves. It can be several meters above normal high tide, like we saw with Hurricane Katrina. Now, our engineers, our scientists, our political leaders, they're all trying to do planning to see what they can do to prevent or minimize the effects of shoreline erosion. One way is to put strict controls on coastal development. This is a picture after Katrina in Biloxi, Mississippi. A man's trying to find his house. We do see a rise in sea level that depends upon three factors. The added volume of water from the melting ice sheets and glaciers, the expansion of seawater as it warms, and the rate of uplift or subsidence along the coastline. You have a landward migration of your barrier islands, so most of our nearly 300 barrier islands along the east and Gulf Coast of the United States or migrating landward as sea level rises. What happens when sea level rises is you have a threaten to your beaches upon which your communities depend upon revenue. Many of your coastal areas will be flooded during storms, and you do have the potential for saltwater intrusion to threaten your groundwater supplies. This shows a picture of how our barrier islands tend to migrate. You can see the lagoon that separates the barrier island in figure A, and notice how from figure A, B, and C, you get that onward migration of that barrier island. Now, some of our resources that we do get from the ocean is our seawater contains a lot of elements in solution. The most common is salt, magnesium. Potassium can also be derived from evaporite deposits. We have what's known as our EEZ, or Exclusive Economic Zone, along the U.S. that extends 370 kilometers seaward of the coast of the United States and its possessions, in which the United States has claimed rights to all resources. We have sand and gravel resources. We have our domestic oil production. We do have some risk associated with our domestic oil production. One of those risks happened when we had that Deepwater Horizon explosion back in April of 2010. It was one of the largest spills in history. We do see some mining for manganese nodules. We see our methane hydrate, which is a chief constituent of our natural gas, being found in this EEZ. This picture shows a picture of what happened and the explosion of that Deepwater Horizon rig. Okay, this ends chapter 15.